Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle. And it says it's untitled by unknown, but it's basically called the title of this puzzle is called the NXT Step to Destruction, and it's by Donatello 86. And this is in reference to one of the setters. I believe it's NXT Master. I think that's his name. Um, so it was basically an ode to that setter. And Donatello shared this with us. Anyways, let's get to the puzzle. We have place the digits 1 through 9 in every row and column. Okay. So that's Latin squares. Okay. Place all 12 pentominoes inside the grid without repeats, regardless of rotation, reflection, or overlap. So you cannot have repeats with rotation and reflection, and pentominoes cannot overlap each other. Each pentomino contains one circle and a cell with a value placed in the top left corner of the cell, which is the sum of the digits placed inside of the pentomino. The digits inside a pentomino do not repeat. Wait. Placed inside. No pentomino is fully placed inside a given region. Okay, so each pentomino contains one circle and a cell with a value placed. Okay. Right. Right, so this has to have a value. That's interesting. Cell with a value placed in the top left corner of the cell. So these are the values of the cell, with the cells. So these must be the top left corner. Oh, no, that's not true. Okay, so basically every pentomino must have one circle and must have one of these cells, which has a value in the top left corner. And that value is the sum of the digits placed inside of the pentomino. Okay? And the digits inside a pentomino do not repeat. So there are no repeats inside a pentomino either. No pentomino is fully placed inside a given region. Okay, so let's explain this. So each pentomino, first of all, you cannot have repeats regardless of rotation or reflection. So you can only have one Y pentomino, you can only have one Z pentomino, one F pentomino, one X pentomino, etc., etc. No matter what the rotation or reflection, right? And each pentomino contains a circle and a cell with a value placed in the top left corner. So you could have something like this cell, or this circle connects to that. And it could be something like this is a pentomino, right? And that also satisfies that no pentomino is fully placed in a given region. And it also satisfies that this pentomino has one cell with a circle and one cell with a value. So therefore, the sum of these digits in this pentomino, if this were the correct pentomino, would have to add up to 15, if that were the case. So that's how pentominoes work. And pentominoes don't overlap either. The grid is made up of 9 regions. None of the given regions contains the digits 1 through 9. So that means there are repeats. There have to be at least one digit repeated in a region because you cannot contain the digits 1 through 9 in any given region. Okay, so that's non-standard Sudoku rules because normally Sudoku you have to have the digits 1 through 9 exactly once in every region, but in this case it's you cannot have the digits 1 through 9 exactly once in any region. And a digit placed inside of a circle counts the number of cells the pentamino takes inside a given region, which includes the circle. So say we did have the same situation here. Therefore, the digit placed inside the circle is the number of cells the pentamino takes inside the given region. So that would be 1, 2, 3 in this case. So this would be 3 here, if that's the case. And interestingly, yeah, that's how it works for the digit inside the circle of a pentamino. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Each circle must be connected to a total. Well, this one seems to be pretty far away from most totals. 1, 2, 3, 4, 5, 6 to get there. 1, 2, 3, 4, 5, 6 to get there. So this must be part of the pentamino with this because this is 1, 2, 3, 4, 5, 6 to get there. This is the only one that can get to 4. So let's mark these. These are definitely part of the same pentamino. Obviously, you have to have boundaries between any circles and any cells that have sums which share an edge with each other. But okay, so we can't see that one. So that's not. We do see that one, but that's not helpful. So that's an edge. That's an edge. I don't think it can go anywhere else here. So you can't. Can you go out here? Can you go this way? No. So you have to go this way. So this is part of the pentamino. And this is to be part of the pentamino also. This could reach here, or it could reach here. This is 1, 2. Can it ever go not in this space for this pentamino? And I think the answer is no, right? 1, 2, 3, 4, 5, 6. No. So this has to be green. So this is definitely green, and it could extend here. It could extend here. It could extend here. It's here. Or extend this way, too. We know that this is a border, though. So this is a border. So this has to be a 1. This is the digits 1 through 5. So this has to be either 2 or 3. It cannot include the 7 because 7 plus 4 other unique digits can never add up to 15. So this is a boundary here for this pentamino. It has to go here, obviously. It could go up to here. So this is 2 or 3 here in this region. This has to be... Whoa, it doesn't have to be 1. It could include that one. This can reach here, potentially. This can only reach, well, it can't get to here because it's blocked by this cell with a number. This is 6 away. It could go here, but the problem with that is then this would have to go here, and then this would be blocked from a number, with the cell with a number. So this cannot go here. This has to go essentially to here. So this pink goes to here. These two have to go to these two numbers here because those are the only ones 5 away. So this has to be 1 through 5 in both of these sets. Okay, so anything with a 15 must be 1 through 5. We don't have any... So the thing is, anything in a circle can only be 1 through 5, period. Right? Well, these two circles must go to these two circles here. This has to be part of this cell here. So let's make this blue, and let's make this, I don't know, red. And these are blue and red here. Now we'll make this gray. Yeah, gray, and then it has to connect to here because they can't reach any other one, right? If it tries to go here, this is blocking that from being in, having a cell with a number in the top left corner. So it has to go to here. It has to connect then. It can't go 1, 2, 3, 4, 5, 6, or it can't go out that way. So this has to connect that way. So this is boundary. This is boundary, obviously. This can connect to that or that. This can connect to one of these 3. This can connect to one of these 4. This can connect to here or here. We're not sure which. This cell can connect to here, here, or here. It cannot connect to here. It could do something like this. That is possible. Could do something like that. It could do something like that. So can this ever be more than 2? No. So this is 1 or 2 cells in the same region. 34 is interesting. That means it has to have 4 cells in the same region because it must be 4, 7, 8, 9. And this is the same here, right? So again, all the circles have to be 1 through 5. So let's remove these. These have to be 1 through 5. These have to be 1 through 5. This must go this way. So let's mark these as red and blue. So these can be blue or red here. We'll mark this as red and this as blue. So red has to go this way. Blue could do, blue cannot include this. 1, 2, 3, 4, 5 doesn't work, so it has to go. Okay, so this could be 1. Okay, this has to include at least 2 digits, so this is not 1. Blue cannot go around. It has to go straight through. So this is blue going here and then connecting to one of these. Okay, so what could green be? We have the digits 1 through 9 9 times each because of the Latin square rule. This can't be 5. Oh, none of the circles can contain a 5, because if they did contain a 5, the problem is it would be all the cells in the pentamino would be entirely inside of that region, which is not allowed. No pentamino is fully placed inside a given region. And this cell must go to a 33 or a 34. This cannot be part of this region because 7 is not allowed to be part of that. This is connecting to either 233, in which case it would be 3, so it'd have to be something like that. 6, 7, 8, 9, or it's connecting to this, which is 34, so this has to be 3 or 4. We don't know which, though. So blue's going here. Could just connect to red here, and then that would be fully red. This has to be at least 2. It cannot be more than... cannot be 4, so this is 2 or 3 here. These digits are 1 through 5. This digit's 1 through 5. We have a 1 through 5 quintuplet in column 2, which eliminates 1 through 5 in the rest of the column. This becomes 6, 7, 8, 9, but no 7 because of 7 in the row. 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9. So this is a boundary here. This cannot be part of the 15 pentamino here. So this is interesting. Okay, so this cannot be going this way. If it goes all the way down here as a red, all of these would have to be 1 through 5. And we'd have 6 cells in column 1, which would require the digits 1 through 5, which is not possible because that's 5 digits in 6 cells. So the red cannot go down to here. Therefore, this is not blue. This is red. This is not red. That's blue. We could have 1 digit here be blue. This is a boundary because, again, it cannot contain... it has to have the digits 1 through 5 to add up to 15 in the pentamino because they have to be unique. This is a boundary here. That means this cannot have 2 digits here. It must extend to here at least. So this is red. Boundary, boundary. This is 2 or 3. So red could continue here, or it could be here. So this is either 1 or 2 here, which eliminates 1 and 2 in the rest of the column because of the 1-2 pair in the column. This is 1 or 2 because it cannot have more. It has 3 of the cells here. Okay, so therefore we do have a duplicate 1-2 guaranteed in this column. Or sorry, in this region, I should say. So it's not going to be the digits 1 through 3. This is 1 through 5 here. This has to be 2. Because it can't be more than 2 in the same region. So this is 2, which means this can't be 2. That's 1, which means this can't be 1. That's 2. So this has to contain 2 digits here. So it has to be like this then. So this is there, and this is there. So that is the region there, and that is a... what shape is that? That is an N shape. So this is pink, already marked there. It adds up to 28 with a 2. 2 eliminates 2 here, so this is 3. That eliminates 3 in the rest of the column, so this can't be 3, that's 4. So this must be part of this region here to add up to 34. Because 4, 6, 7, 8, 9 adds up to 34. 3, 6, 7, and 9. 4 doesn't add up with any digits. Oh, wait, that's not true. Well, anyways, this can't be 3 or 4 because of the 3 or 4 in the column. This can't be 3 because of the 3 in the pentamino. To add up to 33, you could have 4, 5, 7, 8, 9. That works there too. So this is 4, which eliminates 4 here. These, again, have to be digits 1 through 4. Okay, so we have N. We could still have L. We could still have... what is this? Z. We could have T. Those are all possibilities. So this is 1 or 2 here. 2 eliminates 2 in the rest of the column, so no 2 here, no 2 here, no 2 here. This adds up to 28 with 2 and 7. So that means the remaining digits must add up to 19. Obviously, 1 cannot be here, 2 cannot be here. It could be 4, 5, 6, 8, or 9. Oh, this is 3 digits here. So then this must be green here in the region. So that's done as a cell. So the T is green. And this must be 1, 2, or 5, which means we have a 1, 2, 3, 4, 5 quintuplet, or 1, 2, 5 triplet in column 1, which eliminates 1, 2, 5 in the rest of the column. So this has to be 6, 8, and 9 remaining. Well, 5 has to be one of these two, so this can't be 5. This is 4, which eliminates 4 in the rest of the row. So, and this can't be 5, so this is 1, which eliminates 1 here. So this becomes a 2, 5 pair, which eliminates 2, 5 in the rest of the column. So this can't be 2, it's 1. And so this is done here, which eliminates 1 in the rest of the row. This one eliminates 1 in the rest of the column. This can't be 4 because of 4 in the column. No 4 here, that's 3, 5 as a pair. And these cannot be part of this pentamino because they must add up to 15, and 6, 8, and 9 cannot be part of that. So this is border. These are border. And this must continue on to here. So this is an L. So we know this is L. And this must be... no one's available anymore in... and this can't be 6 because of 6 in the row. This has to be 2, 3, 4, 5. Which means the remaining digits in row 1 are 1, 7, 8, 9. Okay. Okay, to add up to 28. 28 minus 9 is 19. So cannot have 8 and 9, because that would require a 2 to add up to 19 there. You don't have 3 available. So minimum 4, 6, 9. Or 5, 6, 8. Okay. Remaining digits to add up to 31 have to be 5, 7, 8, 9? Is that right? 5, 7, 8, 9. This cannot be L, so that cannot go this way, so this is a border. It could be a Y or an I. We don't know which. This can't be L, so it cannot go that way or this way. So this is border here. And this is Y or I. But if this is I, that would force this also to be an I, and that's not possible. So this cannot be I. This must be Y. So this is a Y down here. So this is a blue pentamino, which means Y is blue. And I then cannot be Y also, so this must be gray as an I. So that's done. So this has to be 29 for 4 digits remaining, so it has to be 5, 7, 8, 9. So this is 5, 7, 8, 9, which eliminates 8 and 9 in the rest of 5, 7, 8, 9 in the rest of the row. So this is 6, which means this can't be 6 here. This can't be 1 or 2, so this becomes 3, 4 as a pair here. Okay, so we have L pentamino, I, we have Y. Again, if we made this an I, the problem is this would also have to be an I, because we don't have L available. And it have to connect all 4 of these. 5, 7, 8, 9 adds up to 29, plus 2 is 31, so that works there. So this has to be 3, 4, or 5. Well, in this pentamino, we need a 2, so this has to be 2 here, which means this cannot be 2 here. So where's the 2 in this pentamino? It has to be there. Okay. Yeah, we might have to remove all the borders to make sure that we are kosher with all the other rules. But this is guaranteed to have a 4 here, so this cannot be 4 remaining. You can't have 4 and 5, 3, 4, 5 remaining in column 3 because of the 3, 4, 5 triplet. So it's 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9. This digit is either going to be 3, 6, 7, 8, 9, or 4, 5, 7, 8, 9. So this has to be 5 through 9 there. This is 3, 5 as a pair, which eliminates 3, 5 in the rest of the row. So this can't be 3 or 5. It's 4, which eliminates 4 from being here. So then this has to be 5, 6, and 8 to add up to 19, which is the remaining digits here. So this is 5, because you can't have 4 in any of the columns that these are in. So this becomes 6, 8, 5, 6, 8. Okay, 2 here eliminates 2 as a possibility from this cell. 5 eliminates 5 as a possibility there. This can never be 1. It has to go out somewhere. It could be 2. How does this connect to this cell? Can it, is the question. It would have to go 4 in length, essentially that way. What are the 4 in length ones? N, L, I, and Y. So it cannot reach this one, so these have to be the same region. So this is 4 with 6, 7, 8, 9, adding up to 34. It has to go outside the region. So it could do something like... No, it can't do that because we already have Y. It can't go 4 this way, essentially. So then it has to go 3. So it goes either that way or that way. Or I guess it could go P, right? That's possible. So I think this cell has to be part of the pentamino no matter what. Right? If we try to do something, yeah, funky like that, it doesn't go outside the region. So if it has to connect to that. It could do P, it could do X, it could do F. It cannot extend to here, though. So it could do F that way also. We don't really know. So 34, this has to be, again, 5 through 9 there. Actually, it cannot be 5. It can never be 5. It always has to be with a 4. Can this connect to here? The answer is no. Right? It's an L. So... Right. This must be part of either one of these two. This can never be part of that because all the 4-link pentaminos are taken. So this has to connect to here. It could go around that way. That is possible. So we just know that's part of pentamino. That's part of 1. This cannot reach 4 this way, so this has to be part of that. So let's color those two. It cannot go around this cell, so that's part of 1. This can reach here or here. This can reach here or here. So these two circles must connect to these two clues. So these two circles must connect to these two clues. Okay. Well, either one of these could be 4, so that satisfies that. This can't be 1 or... okay, this can't be 1 or 4. So then this must connect to this one, because if it doesn't, then it's problematic here. Right, because it must be 4 with 6, 7, 8, 9. I guess we can make this light. And light. It could go around. We don't know. It could just go straight through. We don't... this has to be 4. Oh, it has to be 4. It must include that one then. So it has to go around that way then. I don't think there's any other way that it can get 4 in the same region here without connecting. Okay, so then let's remove the boundaries. We don't really need the boundaries anymore. And this will allow us to see the other region boundaries. So this is all 6, 7, 8, 9 here. 4 eliminates 4 in the rest of the row. We have a 3, 5 pair in this blue Y pentamino, so this must be 4 here. This has 4 in its region, with 6, 7, 8, 9 adding up to 34. This can't be 4, which is why we knew that that couldn't be part of this cell. So this must be part of this cell. We'll make those orange. So the light is the U. Orange, don't know. These two, one of these two is part of these. This is part of that. We have 12 pentominoes, so we need to duplicate coloring 3 times. So one of these is yellow, and the other one, I don't know, what should we make it? So let's make this one, I guess we could do medium. So let's make this medium and this yellow. We don't know where that goes to, though. So this is yellow or medium, and this is yellow or medium. Okay. Remaining digits in row 3, we have 3, 5, 6, 7, 8, 9. Okay, ooh. This can't be 6 because of 6 in the column. Now this is interesting. It's 22. This is 31, and it has a 2 or 3. 2 would have to be with 5, 7, 8, and 9. But 3 could be with 5, 6, 8, 9, or 4, 7, 8, 9. Okay, remaining digits in row 5. Okay. Right, remaining digits in row 5 are 1, 4, 6, 7, 8, and 9. Obviously, 1 cannot be part of the orange. 4 cannot be pure because of 4 in the column. So this pentomino's done. This pentomino's done. So is this, so is this, so is that. This is not, obviously. This is not. This pentomino's done. We have PWX. So blue, this blue cannot be X. Where is the X a possibility? Could be here. Could be here. 22. 22. Remaining digits of... that's too broad. This has 1, 2, or 3. So obviously, if it connects to this, this would have to be 3, and then 6, 7, 8, 9. So it would have to be some... Oh. How would that work? I guess it could do that. That could be the case. So if it connects to this, then it has to go here. How does this connect then? So this has 4. So this is either... It could be P. So this other red could be P. It could be X. It could be F. We don't know. It cannot be W because it can't extend any further here. Can it be Z? No. Can it be V? No. Okay. So we have light there. Medium. This could be V, Z, or basically any of them. The other blue could be P. It cannot be W, because that would require it to go something like that, which is not possible. Cannot be X. It could be F. Can it? Actually, no, it can't be F either. Cannot be Z, right? F has to go one way out and then the other way in on the other side, but this is going to be blocked by the edge. So it has to be P or V. Interesting. Cannot be Z either because it has one protruding on both ends. This has to essentially go something like that. And it could go, so as P or as V, I think it has to be a 4. Right? V can go 4 this way, or 4 this way, or 4 P this way, or P this way, but the problem is, well, not the problem, the thing is, every time, in every of those scenarios, this is 4. So this has to be 4, which eliminates 4 in the rest of the box, or rest of the column and row. So this cannot be 4, cannot be 4 here. This can't be 4, so this is 3, which makes this 4. That's interesting. That eliminates 4 from being here. Well, where is 4 in row 5? Can't be here because of the way that it adds up to the sum. Can't be here because we already have a 4 in the box. Can't be here because of 4 in the row. Column. Can't be 4 because 4 in the column. Can't be 4 because 4 in the column. So this must be a 4 here. So this must contain 4 digits in the same region. So it could do something like that. It could do something like that. This eliminates 3 in the same column. So no 3. That eliminates 4 from being here, so it's 1 or 3. This has to be 3. It cannot be 1, because if it's 1, that means it cannot be part of that region, but then 1 plus 6, 7, 8, 9 never adds up to 33. It's too small. So this is guaranteed to be 3, which eliminates 3 in the rest of the column. And it also means the remaining digits in column 5 are 1 and 4. 4 can't be here because of 4 in the row. So this must be 1 and this must be 4. That eliminates 1 from being this cell here. So this is 3. It could be either part of that or that. We don't know. So medium has to have 4 cells in the same region. So this is definitely border there, so it cannot go here. It could do something funky like that. That's fine. It could do something like that. That's fine. Or that. That's fine. So it could be X. It could be F. It could be a lot of things. So we got all the 4s, I think, of it done. Okay. Orange, we don't really have very much information either. So if it's yellow with this, it has to connect with this. So how would it have to be an F if that were the case? And that's certainly possible. 5 eliminates 5 from being here. Remaining digits of column 4 have to be 1, 3, 6, 7, 8, 9. And this can't be 3. No 1 here. No 1 here. And that's fine. Okay. Um... So 19 minus 4 is 15. So the other 4 digits must add up to 15. You could have 1, 2, 3, 9, 1, 2, 3, 1, 2, 5, 7. 1, 3, 5, 6. You have to have a 1 though, guaranteed. Okay. Can this be an F that way? I think the answer probably is no. This has 2 or 3. So to get 3, it would have to be that way. Ah, but this cannot connect through here because it would have to be 1 or 4, including with the 3, and that doesn't work. So this must be part of this. So this is not medium. This has to be part of that. So this is medium. So this has to be 3, and it has to connect. It cannot be a T. So no 3 here, no 1 here. This is 6, 7, 8, 9. As a triplet, we have a 6, 7, 8, 9 quadruplet in column 4, which eliminates 6, 7, 8, 9 in the rest of the column. This can't be 6, 7, 8, 9. It's 1. This is 3. And it cannot be T again. So I think it has to be F to satisfy the 3 in the region. So this is 3 in the region. So this is F, which means this cannot be red. So it's yellow. X is no longer allowed because it's blocked there. So this has to be a P. So red is a P, and it has to be this way. So we have to have a 6 here to add up to 34. So this can't be 6. This is 8, which means this can't be 8. That's 6. That eliminates. This can't be 7 or 8 here. This can't be 6 here. No 6 remaining in the rest of row 5. No 6 remaining in the rest of column 3. So 8 cannot be any of these cells. It's a 6, 7, 9 triplet, which eliminates 6, 7, 9 in the same pentamino. So this is 8. This has to be 9, which eliminates 9 in the rest of the row. So this is 17. So we have red. So this has to be V here or V this way. We don't know. That means we have dark, red, orange, and medium for the remaining ones. We don't know which is which. Okay. This has 4 here. Well, we already knew that, right? It has to go that way or this way. We don't know which. Okay. 8 eliminates 8 in the rest of row 9, which means we have a 6, 7, 9 triplet, which eliminates 6, 7, 9 in the rest of row 9. So that leaves 1, 2, and 5 remaining in row 9. Okay. one of these is a 5. We don't know which. This cannot be F anymore. Could be Z. It could be W. It could be X. Remaining digits of row 4. We have 2, 3, 5, 6, and 9. No 6 here because of 6 in the column. No 3 here because of 3 in the column. This adds up to 31. 3 eliminates 3 here, so this is 2. Okay, so this is 2, 5, 7, 8, 9. So then this has to connect this way because it cannot include a 4. It's 2, 5, 7, 8, 9 to add up to 31. 5, 7, 8, 9. This 2 eliminates 2 here. So this is a 5, which eliminates 5 here, so that's 2. This can't be 5 anymore. We have 6, 7, 8, 9 as possibilities. How many 2s do we have? This can't be 2 anymore because of 2 in the column. 2 is eliminated from being here because of 2 in the column. So it has to go that way. It could go X like that. It needs access to a 5. This has to have at least 2. Can it be 3? Well, maybe. Remaining digits in row 8. We have 2, 3, 5, 6, 7, 8, 9. Obviously, this can't be 2. No 6 here. No 3 here because of the digits in the columns. This does not have, this does have repeats. So repeat 1, repeated 2. This has repeats, a lot of them. 6, 7, 9, or 8. This has repeated 4s and 1s. This has repeated 6 or 8 here. And 3 or 5. This repeated 2 and 4. This has no 4 here. So far, okay, so this is guaranteed a 2 here, but we don't have any other information. There's no 2 in this region, so that's satisfied. This has 2 and a 4. Can it be this way? Okay, remaining digits here have to be no 3 or 4. So 1, 2, 5, no 2, 1, 5, 6, 7, 8, 9. Okay, so where is the 2? Well, that's not true. 2 can be one of those 2. Never mind. So it could be X. It could be W. It could be Z. Oh, wait, it's 2 in this region. Could be W. Remaining digits in row 7. We have 1, 3, 5, 6, 7, 8, 9. No 6 here. It has to have 2 of here. So can it, the one thing it cannot be is Z, I believe. Because Z would have to be something like that. And it cannot enter here because that's another pentamino. And even then, that wouldn't work. It has to include 2, right? And it can't do Z that way. And it can't go that way because that's 4. So... So this can be X. It needs a 5. It could be X or W. So orange is X or W. So it cannot go this way, because if it went this way, the problem is that would block this from having 2 in the region. So it must go this way. So that's done. So this has to go this, it can go that way. So it can go X. It can not go, it could go W. No, it can't go W, because then this would not be 2. It wouldn't have 2 cells in the region. So it can go X, and can it go Z? No, so this has to be X. So we know this is an X. So so orange is not X. So this is medium. W is orange, and then dark has to be the Z. So this is done. This cannot be 1 then. So we're guaranteed a 1 here. This is 2, which eliminates 2 in the rest of the column. This is 5. No 2 here, no 2 here. This is not 5 or 2. It's 1, which makes this 2. No more 5s in column 6. 1 is here. So 1, 2, and 5 add up to 8. 17 minus 8 is 9. So it's either 3, it has to be 3 and 6 in the remaining cells. So that's 3 and 6. 2 eliminates 2 from being here. So this, where's the 2 in? I think that gives us 8 2s, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep, we know where the last 2 has to be. It has to be there. Orange is a W, and it must include here. So therefore, it must go that way. So this is orange, and it must be 5 with 7, 8, 9. So this becomes not 1. We have a 7, 8, 9 triplet in row 5, which eliminates 7, 8, 9 in the rest of the row. So this can't be 7, 8, or 9. It's 1, which eliminates 1 in the rest of the column. So this is not 1. This must be Z, and it cannot extend 4 that way, so it has to be 4 that way. So that is done, which means 6 cannot be remaining in the region, and it cannot have 5 here, or 5 here, because of 5 in the column. Because again, this must add up to 31. We already have a 2 there, and it must be 5, 7, 9, 8, 9 as the remaining digits. So where's 5 in this set of 31? It has to be here, so that eliminates 5 in the rest of the column. That eliminates 5 here, no 5 here, no 5 here. We have a 3, 6, 1 eliminates 1 in the rest of the column, so this is 7, 8 as a pair, which eliminates 7 and 8 here. This is 1, so we have 1, 4, and 6 here. Therefore, these 2 digits must add up to 22 minus 11, which is 11. So this has to be a 3, 8 pair. Because that's the only, we don't have 2 available, and that's the only other pair. You can't have 4, 7, can't have 5, 6. So that eliminates 3 and 8 in the rest of the row. No 8 here. Therefore, 3 and 8 eliminate 3 here. So this is 5, which eliminates 5 in the rest of the row. And 5 in the rest of the pentamino. So this is 3, which makes this 5, and that 3. We have a guaranteed 8 in one of these 2 cells, so this cannot be 8 here. In fact, we have a 6, 7, 8, 9 quadruplet in column 6, which eliminates 6, 7, 8, 9 in the rest of the column. So this is 3, which makes this 6. That eliminates 3 in the rest of the row here, and 6 in the rest of the column here, and the rest of the row here, here, and here. Okay. So each region, this has a duplicate. Okay, so this region does not have 1 or 2. This has duplicate 1 and 2. This has duplicate 2 and 4 and 5. This has duplicate 3. This has duplicate 1 and 4. This is duplicate 2 here. This does not have a 2 available. This has duplicate. This has no 1. And this... Huh. 3, 8 as a pair. So this has 4 cells in the region, 2 in the pentamino, 1 in the region, 1 in the region, 2 in the region, 3 in the region, 4 in the region, 3 in the region, 2 in the region, 4 in the region, 4 again in the region, 2 in the region, and 4 in the region. So this adds up to, you cannot have a 1 here. So where is the 1 in row 7? It has to be here. So this is 1, and we have to have a 5 somewhere in column 9. It cannot be here. Cannot be any of these, so it has to be here. So this is 5, which eliminates 5. This is 7, 8, 9 as a triplet, which eliminates 7, 8, 9 in the rest of the row. So this has to be 3, which makes this 8, which makes that 3. That makes this 9. That makes this 6. So this can't be 9 or 3. It's 5. None of these can be 8 here. We need an 8 in this pentamino. That forces this to be 8 here, which eliminates 8 in the rest of the column and row. And this cannot have a 6 in the rest of this pentamino. We have a 7, 9 pair, which eliminates 7, 9 in the rest of the pentamino. So this is 8. This can't be 7 or 9 because of the 7, 9 pair in the row. So this is 6. That eliminates 6 in the rest of the column. So no 6 there, no 6 there. If this were a 7, that would force this region to have the digits 1 through 9 exactly once each. So this cannot be 7. It's 9. So this is 9, which makes this 7. Also, 1, 2, 4 is 7, plus 7 is 14, plus 5 is 19, so that works. 9 eliminates 9 from these cells here. This can't be 6 either because of 6 in the column, so this is 7, which makes this 9, which makes that 7, because you can't have duplicates in the pentamino. This can't be 7 or 9, it's 6. 7 eliminates 7 here, so it's 8 and 7. This can't be 7 or 9, so it's 8. This can't be 7 or 8, so it's 9. This can't be 8 or 9, so it's 7, which eliminates 7 in the rest of the row. So this must be 7 here, which makes this 9. 7 eliminates 7 here, so it's 9, which makes this 8. No 7 or 8 here anymore. No 7 here. This can't be 9, so this is 8. No 7 here. It's 6 or 9. And neither of these could be 9. And the 7 eliminates 7 in the rest of the pentamino. So this is 6, which makes this 9, which makes this 6, which makes this 7. And this 7 eliminates 7 here, so that's 9, which makes that 7 there. And that's a solution. Very cool. Very, very cool little puzzle. It was interesting of all the rules that you have to go through, but it went through very quickly, or not quickly, but smoothly, I felt. And just sort of one led to the other, one led to the next sort of thing, right? At least that's the way I felt about it. And especially because of the way that the numbers worked with the circles, right? And then each pentamino having to have a different shape. Yeah. Just worked very well. Very cool puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.